didn't do it with matrices for a long time. I'd kind of fudge my way through. But you need to use matrices. Matrices is the right way to do these problems. You'll see matrices again. You'll see them again in this class. You'll see them one more time. But matrices is how you abstract what you're doing in one dimension to multiple dimensions. So the toy example I have, toy example means I expect you know how to solve this if given to you, left to your own devices. But you have a system of equations, and everything I have here works if I have n equations and n unknowns. I get that. I'm going to just do this toy example for you out, and then I'm going to send you to boards and have you do 1 through 4. So you're going to do a little bit of monkey see, monkey do, but I want everything labeled out. One of the things I have you do in this word problem is I have you actually write out your variables. Remember your algebra teacher saying write out your variables, 1 point off if you don't have your variables written out. Remember all that? And then some of you just didn't want to listen to her. Nick, him, you didn't want to listen to him. And so you skipped that and you lost your 1 point. So I just take the hit for 1 point. You do that now, you're about to have like 15 equations and you get tangled up. So it's not for the toy problem that people ask you to do the variables. It's actually for harder problems. And we're going there. We're soon going to go there. We have lots of variables. So you do have to list them out. So in this toy example, I don't have the problem. I'm going to pretend that that's all been bypassed. This is just the mechanics. Step 1 is to make out what we call the coefficient matrix. And what that is, that's the matrix of the coefficients. So where I had the 2, it goes right here. Where I had the 3, it goes right here. I'm going to pause and make sure everybody knows where that comes from. Everything is clear where that comes from. So all the coefficients get dropped into a box. Step 2 is to make the vector of the right-hand side. So the right-hand side vector is 16, 14. Every mathematician knows what RHS means. It doesn't mean Randolph High School. It means right-hand side. And notice I put the little vector symbol out here. And then you're going to toss your variables, your unknowns, into a vector as well. The first component is going to be your x, and the second is going to be your y. Sound a little familiar? It should be a little bit familiar because we were doing this with the, solving for things when we're using the vectors, and I pulled out the first component, pulled out the second component. And what you'll notice is if I take this, my original problem can be rewritten in this form. You might not see that, but yesterday I tried to quickly show you what matrix multiplication was. And if I just back calculate and show you my check on work, there's my A, here's my X, there's my X. If I multiply that out and I take the first row and dot it with the first column, I get 2 times X plus 3 times Y. If I take the second row and dot it with the first column, I get 4 times X plus 1 times Y. This was a 2 by 2. This was a 2 rows, 1 column. My answer should be a 2 by 1. It should be, yes, 2 rows, 1 column, and it is. All right, Cat's face is very expressive right now. Let me see if I can color code this. Let me do this again with color coding. Here was the 2, here was the 3, and I'm going to put this in blue. 4 and 1 was here. And then I'm going to put the X and the Y in black. This is a pain, but I'm going to do it this way. If I took the red as a vector, I consider that row as a vector, and I dot product it with the column, I get the red would be 2 and 3 would go here, and dot product would give me the X and the Y go here, and I sum. It's a dot product. The same thing would be true for the second one. You do the same thing, but it's the everything's with the second row.
And that's for when you're multiplying.
When you're dot producting the row with the vector. Dot product means that you that this is the process for dot product, right? Let's see.
The second number.
Yes. So that's what dot product does. You take row and dot, you take the formula for dot product. If I have a vector 1 and I have a vector 2, when I dot product them, I do this. I multiply x1 and x2 and I add this. You did this in your last problem on the PSL. Yeah, you did.
I shook my head. I got 5.
Maybe in the last minutes of class, I'll have somebody help you. Yeah, Sam says he's got it, so he's gonna teach. It was good. It was actually when you come in for AI, I learned so much because I'm up here and I don't. If we just did a linguistic analysis of who's doing the talking, I'm doing all the talking, so I don't really know what's going on in your heads. And then when I see that, it just gives me a better idea of how to explain it. All right, so I would like you to take boards and actually, well, but let me stop here. One more thing. That's supposed to be equal to B. The B was 1614. The way to vectors can be written this way or this way, a long way. So this one's written a long way, and you set the components equal, and you get exactly your first equation back for that first equation, and the second row would be the second equation. You get it back. And why the heck would you want to do this? It's not for 2 by 2 things. It's for 15 by 15 things. This machinery allows you to work with big matrices and big sets of equations. We're not going to be able to do those by hand. You're going to be plugging them all into Excel and using something called Solver to do it. But this is what it's doing. It's doing this kind of machinery underneath it. Matrices is how we work with real stuff. Nobody goes, I've never been asked in real life to go solve 2 equations and 2 unknowns that are linear, other than teach it. If I wasn't a teacher and I was only a researcher, I would never have to do that again. Nobody, that's not what they're trying to do for you. They're trying to get you ready in case you see something harder. You're about to get to that. You're about to go there. All right. That makes you all happy. You always asked, what was I going to use all this for? Well, you're going to find out. You asked, we're going to answer. Go ahead.